In this video, we're just going to look at quick operations when we have variables inside them. It's very, very basic. So this is kind of really the entry, like I have no idea what variables are, etc. Then you can look at this video and can maybe help you a little bit. So in this case, you can see there's 4 plus x is 5, and this x is just a variable. It's just an unknown number, and it just says, hey, there's a certain magical number. If I add this magical number to 4, I get 5. And you should know, hey, okay, that's probably going to be 1. So it can be anything, but in this case, it's 1. So we can do certain operations with numbers, with variables. So we can multiply. So if I say there's 4 times x, or 4 times a certain number, I can shorthand write that as 4x. So it just means 4 multiplied by x. So in this example, for example, I'm saying example a lot of times, 4x means 4 times x, plus 3x just means 3 times x. And this 2y just means 2 times y. So if x was example for, let's say, 4x, if I said x was equal to 2, then this would be 4 times 2, and that would be 8. Or 4, sometimes we can write it with a little bracket. 4 times 2 in the brackets means 4 times 2, and that's 8. So this is how we would write that. 4x, and if I had 4 divided by x, that would just be 4 divided by x. So I think let's say the fundamental thing that a lot of students get wrong is if you write x plus x versus x times x. And these are different operations, and we're going to get different results. So if I asked you what is 1 balloon plus 1 balloon, then you'd probably have 2 balloons. So whenever we have x plus x, we get 2x. Now the x's are the same, and therefore we can add them, and we just get 2 of them, or 2 multiplied by this number. You can think of it like centimeters. If I measured something and we got 2 centimeters, maybe I measured something and it was 2 centimeters long, and I wanted to add something that's 3 centimeters long. 2 centimeters plus 3 centimeters will give me 5 centimeters. So this is just the unit. So it could have been 2x plus 3x. It just gives me 5x. But if I worked out area, then I wouldn't, like, this would be distance, right? So 2 centimeters plus another 2 centimeters. But if I wanted to work out the area of something, let's say there was a room and it was 3 meters by 2 meters, in that case, I would say to find the area of the shape, I'd say 3 meters times 2 meters. And I would do 3 times 2, which is 6. And I would say, well, my new unit is meters squared, because I'm working with a different unit now. I'm not working with meters, because meters is length. I'm actually working with square meters, and square meters are little blocks. So there's a difference between a meter and a square meter, and I can't add a meter and a square meter. I can't say, well, I measured 2 centimeters and I want to add 3 centimeters squared. I can't do that. That doesn't really make sense, because this is a length and that is an area, and I can't really add them. Coming back to my example, x plus x gives me 2x, just like 2 centimeters plus 3 centimeters would give me 5 centimeters. But when I multiply x times x, then I get a different kind of unit, so to speak, and that becomes x squared. Now, with multiplication and division, it's kind of, you can do a lot of stuff and you don't have to even think twice. But as soon as we adding and subtracting, you kind of have to stop and think, and like, hey, can I add these things? Can't I add these things? So the very important thing to know is that you can only add like terms. So in this case, I have 4 x's and I'm adding 3 x's. So that would be 7 x's, right? So that's 7x. Here I'm saying 4x plus 2y. And because I'm adding, I can't add them to get now suddenly, I don't even know, 6xy. That's not going to work. It's like saying I have 4 apples plus 2 bananas. And then if you have 4 apples and 2 bananas, you don't have 6 apple bananas or something. So you can't really add these things. So these are not like terms. So just like you wouldn't add a centimeter plus 3 kilometers, you have to kind of convert them to be the same units before you can add them. So in the same way, you can see these variables as units. You can't add units that are not the same. So we usually talk about like terms. So let me write a couple of examples here of when we add these types of variables in algebra, what can we add and what can't we add? Okay, so let's look at this. So let's say we had 2x plus 3y plus 4x plus y. And I mean, I can put a very, very long thing here, but all you need to do is you have to figure out which ones are like terms. So this is x, and that's y. Here's another x, and that's a y. So the like terms, the things that are the same are the x's. So these are, let's say, 2 apples and 4 apples, and that would give me 6 apples. So I can add those two things. They'll add up to this. Or usually let's say if we did it in a test or something, we'd say, okay, well, 2x plus 4x, that would give me 6x. And the y's, there are 2 of them. And you might be a little bit confused now because you see there's a 3 here, but there's nothing in front of the y. So you're like, okay, but what is this? There's actually a magic 1 here, which we don't write because it's very annoying for us to, whenever we have writing an x or a y, to write a 1 in front of it. It just gets annoying. So we leave it out and it's kind of there and we know it's there. So in this case, when I have 3y plus a y, you can see it as I had 3 apples, or was x the apples? Let's make the y bananas. I have 3 bananas and a banana. I don't have to say I have 3 bananas and 1 banana. I can just say 3 bananas and a banana. So 3 plus 1 is going to be plus 4, in this case y, or bananas. And this is the furthest we can go. We can't add them. But the magic thing is we could have multiplied them. So if we had this example and it was all multiplication, we would actually get to one term. In this case, terms are split up by plus and minuses. So here we have 4 terms, and when we add the like terms, we have 2 terms. So if I had to, let's say I had an example like 6x times 4y. This I can actually simplify and say, well, 6 times 4 is 24, and x times y just becomes xy. We'll look at multiplication a bit later. I'm just focusing more on plus and minus now, but I just want you to realize that when we add, we can't add things that are not the same. Although we can multiply things that aren't the same, we can't add or subtract things that are not the same. So let's think about just a quick another example. Let's say I have 2x minus 3x plus 2y minus 9y. So here the like terms are kind of together, so it makes sense. So I have 2, but I take away 3. So just like 2 minus 3 is going to be minus 1, 2x minus an x is going to be minus 1x. I don't have to write the 1. I could just write negative x. It's implied that there's a 1. In this case, I have plus 2y minus 9y. So I had 2 of somethings, y's, and I subtracted 9, so that would be negative 7y. Again, I can't take this any further. These are not like terms. I can only, it sometimes helps to underline them or do like little scratches or whatever so that you can see which ones are like, especially have a little long a row of these things. Okay, let's do something a little bit more advanced. I don't want this video to be too long, but if you get what I'm saying, obviously you don't have to watch the rest, but just for those that are kind of still a little bit weary with these kind of variables. So let's just do something like this. So in this case, I have 4x plus 2x squared plus 7x plus x squared minus 3x. And a good rule of thumb is underlining the ones that are like terms. So this is 4x. This looks very similar, but this is x squared. So this is not the same. This is 7x again, and this is not the same because it's x squared, and this is minus 3x. So I can say 4 plus 7, which is going to be 11, and then I take away 3. So hopefully, if my math is correct, that would be 8. And the other thing that I wanted to check, okay, let's see if I have a different color. I don't really have a different color. Oh, well, I have this one. So in this case, I have 2x squared, so I can do a little squiggly there, and another 1x squared. Although the 1 isn't there, I'll write it in just for us to see. And in this case, we have 2 of them plus 1 of them, so that would be plus 3x squared. Okay. But again, we can't go any further because this is x and that's x squared. I can't add an x to an x squared. They are not like terms, just like I can't say 3 centimeters plus 2 centimeters squared. This is a length and that is an area. So we can only add like terms. Okay, I think that is that for this video. In the next one, we're going to look at when we multiply these variables and see what happens then.